Can you describe how Bitcoin's identity system has led to this decentralized identifier or DID system that we're now seeing take hold?
Yeah, so Bitcoin is, like I said, is the first decentralized public key infrastructure that's been run at any scale, and certainly works. Doesn't suffer a lot of the problems that early attempts have suffered, and it's interesting because the core problem of decentralized identity, having identifiers that are wholly and solely yours, that really can't be interdicted through any centralized bottlenecks, is like a 40-year problem. It's a 40-year-old sort of holy grail problem in the digital identity community. And it really honestly comes down to recording like a time sequencing oracle. That same thing that Bitcoin solved is actually the underlying problem in digital identity systems, which is typical identity systems of the past. You would have like some identifier. DNS is a really good example. You have domain name, and how do you tell over time who owns it? Because they could be sold, or they can, you got to prove control over time. And there was sort of no deterministic state machine out there that says, well, I recorded entries of who owned what. So if like a key changed, right, in typical DID systems, you'll be able to like map a DID like devices that you control, so you could do things with it. And those things change over time, right? I might get a device and switch it out, and now I have a different key associated with it. I have to record those state changes, because the minute you say, well, just trust me, right? It's this state, it's these keys. That's the point of centralization. And that's why we have the CA system of today and all these other things, is because there was no system for that. So they created these hierarchies where they basically just say, well, we ordain this organization over here, and they give you these magical certificates, and just trust us. And if we want to wipe you away, we can. That's why when you go to certain sites, you'll see all these nice 3-letter government badges on there, because they do assert that they certainly do own that system from time to time. DIDs change that. There's no one in the middle. Like, there's no one that's going to come and take this stuff from you. So, well, sans a $5 wrench attack, I suppose they could show up at your house and do what they do. But that's the huge difference, and that's what Bitcoin did. It solved the chronological oracle problem, which is really the capturing of state from inception of every change in PKI. And it did that really elegantly, and that's how like we're building DID stuff on top of that foundation as well.
Right. Now, Bitcoin has its own system for securing the network, right? Like, it has hash rate, it has nodes, it has an entire incentive system wrapped up in the token that secures the token, and gives it, it makes it so that people can store value in it. What's that system for DIDs? Like, how do you secure a DID? How do I establish, if I get a new phone and now all of a sudden it's a different key, like, how do I make that transfer trustlessly? That stuff's still a little unclear to me.
Yeah, absolutely. So there's, one thing you brought up, specifics of DIDs. Like, maybe I'll give a little bit of a background, right? So DID, the decentralized identifier spec in W3C, which is still in limbo for final ratification for reasons that people probably have read about over the past year. It's essentially a data model spec. So when I say data model, I mean it is not telling you how to build a DID system or implementation. It's telling you what things that must include if you were to build one, right, from a higher level. And then it's this output document format, kind of like if you resolve a DNS name, a domain name today, there's a zone files, and there's like, backing DNS documents that are resolved, like name servers and CNAMEs, A records, all that stuff, right? That's all standardized. Like, that's a data model for the pieces of information someone looking up a domain name needs to have so that their computer can find the right resources, right? The decentralized identifier spec is analogous to that. It sets out the sort of JSON document format that contains two primary things that map to an identifier in your implementation. One is public keys, so the person presenting the identifier can prove that they own it, and then the other is endpoints. Because DID systems don't actually and shouldn't contain actual identity data. That's not the purpose. Their purpose is more like DNS. You wouldn't like encode your website into your DNS records. You know what I mean? It's just for triangulation and security. So you're saying like, I present this ID, here's keys to prove it, and you can go over here through this decentralized routing mechanism to find information about the ID if I want to disclose it to you, right? So that's a key thing, because people freak out. They think we're going to like putting personal information on a blockchain, or ION, which is one implementation, like putting it in there, and that's just not true. It's very much like a DNS lookup.
Okay,
So, yeah, go ahead.
so Ion is a implementation of this decentralized, this DID modeling, right? This DID data model. Is that the idea?
That's correct. Yeah, and there's many different implementations. Like one simple one that everyone can kind of grok is like the simplest DID method is this. I call it a toy one because it doesn't have all the features, but like did key, like it looks like a URI like did colon key and then public key. So it's literally like you're just handing someone a public key, and you prove control because you own the private key. There's some issues with did key. You can't roll that key. So if there's ever a need to switch it out, or you need another key type that you want like multiple keys associated with it, it's tough because you're bound by that one key, and you just don't have the flexibility. And then it doesn't have like endpoint support, stuff like that. But there are very simple ones. There's centralized ones like did web, where it's basically just somewhere on some domain hosts this document. And the problem with did web is I could see the Googles, the Facebooks of the world liking this because it's not too far off from what they have today, which is just a slightly standardized means of a centralized person kind of owning your identity. Because if they own the domain that it's actually rooted on, they own your ID. So that's why we encourage people to use truly decentralized implementations of that spec, not just any particular random one they find.
Okay. I'm still trying to understand a bit about like how you ensure this, like if we take
Security?
Ion, for example, yeah, how do we ensure it's secure, and how do we ensure it's stable?
Yeah.
And
So the DID systems have a different sort of requirement set. I would say, taking Ion for example, the base requirement set is that you have some record of history that is as deterministic as you can get it, as decentralized as you can get it, that understands and records the state changes of an identifier's PKI information, whether it's like I changed a key or I changed an endpoint to where my data might live. It has to record those changes over time and replay them. It's sort of like it's the ship of Theseus, the classic identity example of, the ship of Theseus is leaving from a dock and it's like a black ship with red sails, right? And over time, over the journey, which is like your PKI state changes, every board and nail's replaced and, sails are removed and changed. And if you were on the dock when it left and you sort of saw the ship coming back that was like brown cedar and it's like green sail, you'd be like, well, I think maybe that's the people. But is it the ship of Theseus, right? If you don't see the state changes, you just have to trust them. It's like, no, that was them, right? Trust us. But if you could see every nail and board replaced, then you can understand the assembly, right? It's sort of like the compilation over time. And so any good DID system has to solve that problem. I mean, that is the chronological oracle problem. Bitcoin does it because its state changes are codified into Bitcoin blocks, and they're sequentially numbered, and they count upwards. So they are, and that's why he called it time chain to begin with, right? Is because it really is. It's capturing events in synchrony over time, and you have the ability to replay them. That's why when you boot up a node, you have to like process certain things in order. So that's actually what Ion anchors into. It's not so much like open timestamps concerned with point in time publication. Like people will look at our systems, it's just like timestamps. It's actually a much more complex protocol, and it's not just saying like there's some hash of some data and it existed at this point, at least here. It's more like there's operations to a DID, like create, update, recovery, that happen over time, and you need all those associated in the correct order. So it's much more concerned about sequence and order than it is proof of publication at an exact singular point in time, orthogonal to anything else. So Ion is a layer 2 deterministic system. It doesn't have its own consensus. There's no like validators or special authorities in the system. It's kind of like Lightning spiritually, even though the protocols are very different, at the code level, in the sense that anyone can participate in Ion's network just by running a node and sort of anchoring things in Bitcoin. And how it works is, you can anchor 1 to 10,000 of these DID operations, which could be Alice creating an ID, Bob updating to roll his keys to a new device, whatever they are, right? You can anchor 1 to 10,000 of those in one Bitcoin transaction. And it uses an IPFS hash inside that anchor. And what all the nodes basically do is there's no agreement on consensus that's subjective. They all go get those operations and they just compile global state. So they're trying to replicate. It's basically a huge mirroring network. They just all want and are interested in these operations. And when they have them, it's just math. I mean, they just compile them. There's no like, let me ask my neighbor what this should be. It's purely deterministic. And what I would say, in terms of incentive structure, right? So That's how it works secure in security terms, because where it falls in Bitcoin determines the, the outcome. So that's secured in, in the actual functional terms. Now, monetarily, you asked kind of like, well, there's a token and it backs this, right? People say, well, why would I run an ion node? And I'd say, well, there's two really important things in life. There's money, right? You want to own your Bitcoin. And then there's identity. And it turns out that to do really anything in the world, you kind of need to know identity. You want to know that this bank is a legit bank. You want to look them up. You want to, you just met this person at a conference. You want to give them their, your ID. Maybe you exchange one, right? Mm-hmm. All those things require identity fundamentally. So the reason why people would run an ion node, or at least, companies of any size, that sort of thing, is because they want to be able to interface with customers, individuals, and partners. So if I want to look someone's ID up, I better have a way to do it. So it's sort of like a utility-based need. Like the reason why you run it is because you need to run it. It's not like a question of can you run it. It's like you just have to, because you want to resolve your customers. I always give like an insurance example. Like if I'm Allstate and you tell me I need to run this system, that's going to give me better connections to my users, like higher trust, greater proof, better security, for all these like business type purposes. And I say, hey, you got to run a server. It's going to cost like, I don't know, you put a guy on it, it's probably cost like $1,000 or $2,000 a year. The costs are minimal, like in terms of the actual operation costs, more labor, I guess, to have someone watch it. And they're like a, $50 billion, I don't know how much they're worth, like $1 billion company. Yeah. They're going to laugh at you. They're going to say, oh, $2,000. Oh, no, what am I going to do? Of course I want to authenticate my customers for $2,000. Right? Mm-hmm. It's like a rounding error. So they don't need a shitcoin to convince them to run this. They're going to run it because they want to like validate the driver's license of the person they're trying to give insurance. You know what I mean? If that makes sense. Mm-hmm.